Thank you, good morning, and welcome all back. It's my great pleasure to introduce Mimi McClure from the National Science Foundation. When she told me that she's going to come for the workshop, I said, are you willing to speak a couple of minutes about NSF and the program? I think there's a lot of people here from academia who actually receive funding from NSF, and it's always nice to hear what's happening in the future and what's going on. So Mimi's going to talk about this. Mimi has actually been a long-time public servant, doing a great job at NSF for many, many years. She started at NSF in 2002, if that's correct? 2002. Actually in the graduate education division. So if there's graduate students here, you might want to grab Mimi at some point in time during the day and then, learn a little bit about what she did at that time and how, NSF works with graduate students. There's very interesting programs, fellowships. She then moved on to OCI, supporting their a bunch of programs. And since 2009, she's actually senior program director in Computer Systems Research division of part of SAIS. And that's definitely an area where a lot of us, are very interested in and do a lot of research. So thank you, Mimi, for coming, and thank you for giving us a little bit of an overview of what's going on at NSF these days.
Thank you. I'm very glad to be here. I see a lot of faces I know, and I've met a lot of new and very interesting people, and the conversations have just been really, really enlightening. I'm going to give you a quick overview of CCRI and a few of the other things that we're doing. I think one of the biggest changes coming to CCRI is that Harriet Taylor is leaving and I will be taking over the program. So I will have both computer systems and CCRI to run. I'm not looking forward to that in a lot of ways because it's a lot of work. CCRI is ever evolving. It came from CRI. CRI had both an institutional part and a community part, but what we found is that we were funding individual clusters for institutions, and then people were coming back every couple of years because they wanted new ones. And it's just really hard to make an impact if you're spreading everything so thin. So we decided that it was time to go bigger and go with community building and community development. And by the way, if you are interested in looking at large collaboration building, we are going to have another workshop. We had one a couple of years ago. We'll be running another one in the fall. Send me an email and I'll get you on the list. These are some of the significant CRI community infrastructures that we have funded. The CCRI rationale is that it's focusing on community infrastructure that is very, very, very size-centric. It's building research infrastructure that size researchers are going to use that have an impact on size research. Other people can use it, but those kinds of broader infrastructures are usually done by OAC. They keep changing their name. We established, we're looking at world-class enhancement of infrastructure that really will focus on size. It's run by the 3 divisions. There is a leadership team that includes at least one person from all 3 divisions. I've actually been on CRI since 2008 or 7. So I've watched it grow and develop, and it will continue to grow and develop. It sort of fits in the big picture of how we do infrastructure, and this is not exact. This is kind of an idea of where the infrastructure programs are, but it gives you an idea of other things that you might look at as you are building and growing and expanding. Okay, button's not working. Yep. Nope, didn't work. There.
Okay, we'll just have to have it that way.
Let's see if this is. Okay, you should be all set now.
Okay. And these slides will be made available, so what we gloss over now you can look at a later date if you're interested in. We have 4 types of programs. We encourage people who are looking at larges or the grands to do a planning grant first and spend the time putting your team together and really thinking about how the team is going to integrate. And then we didn't want to really map after core where you have smalls, mediums, and larges. We wanted to go up and get rid of the smaller grants because there's not a whole lot you can do there with community, and do larger grants and grands, and then still add to the enhancement and the sustain, because sustainability is always an issue. And we are forming a virtual organization, and let's see. Some of the funded projects impact all different kinds of physical robotics, parallel programming. Security is always an issue. Cyber infrastructure, big data. Data is always a problem, and everybody's always looking at what am I going to do with my data? How are we going to get it? Where are we going to store it? Who else can use it? So that's always a big issue. A little bit about the last round of funding. We have not made this next round of funding because we haven't run the panels yet, but we are. So we made 2 grand awards last year. One was Coliseum. One was Open Cloud Lab, which you'll hear about in a little bit. And a recap. I talk fast. CCRI is an ongoing experiment, and it really is an experiment, and we change it and enhance it as we see the needs of the community. And so if you've got ideas, please let me know. Don't tell me, send it to me in an email, because I'm not going to remember it if you tell me. The funding, so we were flat budgeted for about 10 years. We got another $7 million to do this next level of CCRI, but it's still, the competition is brutal. Because the date was so late this year, we actually are down in the number of proposals that we got. So our funding success will look bigger and better, but that's a date issue and that won't last for forever. And we're always going to need more money. And so making the case to your congressman, your other program directors, our AD as she comes around and talks to people, our division directors, it's important. You're the messenger. And it's for size and size alone. And again, sustainability is a big issue. So we are looking at the first PI meeting that we are now talking about not having in June. It may be later in the fall. We just sort of need to see how health issues pan out, but you will be hearing more. And some of you have been asked to be on the advisory committee for the VO. Please say yes if you're asked. It's a great way and an important reason to start off strong. And I'm done.
That was a nice brief overview.
There's a lot more detail on the slides.
Well, and you'll be around for the rest of the day, right?
Yes.
So if you folks have more questions, but we can take a couple questions right now if there are questions.
I'm surprised. Nobody's going to ask about the institutional stuff. Those are usually what I get.
Am I doing this right? You want to just...
Thank
Ron,
you.
are you coming over for a question? Wait.
Oh, okay, question.
I'm curious, so like one of the things that we're really excited about is actually now it's kind of expanded the Open Cloud Testbed with the industry support and things like that. Is that a common program? Like, and how, I mean, there's always concerns about the relationship of industry to the NSF funding, and are there any dangers we should be cognizant of in doing that?
Actually, NSF is really embracing the industry partnerships a whole lot better. We are actually creating some. We find that the research ends up getting a whole lot more targeted and focused, and you end up with something at the end that's far more applicable and maybe even helps with the industry bottom line, which is important for industry.
Any dangers that you've come across in those kinds of collaborations or that expansion?
It's not so much danger. There's a lot of negotiation in the IP. you know, who owns what and how it, where it goes, and you guys tend to hold things close to your chest until they're published, and sometimes it's a little harder to do that when you've got a shortened time period and a very focused research effort. But no, industry partnership and helping us grow them. If you've got strong partnerships and there is a problem that's targeted and focused, I'd love to hear about it.
Yeah, a bit of a meta question, and I apologize if I missed it in the beginning of the slide deck. The abstract and the internet in general don't seem to be able to tell me what CISE expands to as an acronym.
Computer, Information, Science, and Engineering.
Thank you.
Thank you.
Okay, thank you very much. So you now know all about the process. If you are interested in CCRI, this is the process we went through. So good morning, everyone, again. I'm Mike Zink from UMass Amherst. I have the honor of representing the Open Cloud Testbed project, which is a CCRI project. It's been a lot of fun. We got funded in sometime over the summer. We really started in October. I have the pleasure of working with two of my long-term colleagues at UMass, David Irwin, and our French race driver, Emmanuel Kekchet, who are sitting somewhere in the back here, if you just want to wave your hands. Actually, I've also known Peter Desnoyers for many years because he was a grad student at the time when I started at UMass, before he fled the nice part of Western Massachusetts and went to Northeastern. And then I've now known Oran for many years, and met recently Miriam and Martin, which is also a pleasure to work with, and I'm learning about FPGAs quite a lot in the last couple of months. So it's been a nice start. It's a very nice team here. You see all the names on, and it's a nice collaboration with the folks from Northeastern and Boston University. What I also want to say, it's not just that, it's way beyond that, and I hope in the overview yesterday we could give you a nice overview, a nice idea of our collaboration with research IT at BU and Harvard with Wayne and Scott, with the folks at MGH-PCC. I see Jim Colbert this morning. I don't know if John is somewhere in the room. Cannot see him right now. But, oh, hey, I'm sorry, right in front of me, John and the team working there. John Griffin is here, research IT at UMass, so a lot of people, the folks at Red Hat, the folks at the OpenStack Foundation. It's been a nice collaboration so far. But let me get to the meat now of what we're doing, right? So there's a little bit of a recap from yesterday. Some of the stuff is some of the stuff I addressed already yesterday because we have a couple new people in the room this morning, so I apologize for the redundancy for those who have been here yesterday. So cloud computing plays an important role, and I think we can say check because we have all heard this many times right now, but it also plays an important role in the sense that there's a lot of research going on in this area, and we want to support this kind of research. And a lot of the systems research, I hope you all agree with me, is also based on having test beds and having tools and having resources to try out new ideas, to prove concepts, and to evaluate your new ideas. So that's important. So they're critical. We have seen since 2014 with the establishment of NSF Cloud test beds with Cloud Lab and Chameleon that they are highly popular. There's lots of people using them. They're actually so popular to the extent that the demand is often higher than the available resources. Rob, this is actually a figure I stole from your ATC paper. You might be very familiar with that. So if you squint at it, let me just explain that. The high-level information is when you get close to big systems conferences deadlines like NSDI, like SIGCOMM and so on, that there's more request for resources than are actually available in Cloud Lab, for example. And Kate, unfortunately, is not here today, but if we would talk to her, it's probably not going to look any different in the Chameleon Cloud. So that's one reason is, we would like to have, as a research community, we would like to have more resources for our experiments. And the other thing is also, we've seen this throughout the last couple of days that, as researchers, we're building things in the long term that hopefully have a broad use, right? We're not just doing this for us, we're doing this for applications, whatever's on the cloud, right? To make the cloud more efficient, to make the cloud more reliable, to make the cloud more secure, all these kind of things. But how do we show that, right? So if we can actually have real users of our approaches, that's a nice thing. And so here's where the mass open cloud comes in, because that's a cloud, that's an operational cloud that supports real users, gives access to real data sets. We can actually get traces, right? So we can use these traces for analysis, for maybe sometimes for doing simulations and so on. We can actually allow the services to be exposed to the end user, so transition to practice. It has a lot of connections to production service. We talked about the New England Storage Exchange. Yesterday you heard about that, where we have huge storage available and other services that are in the larger MGHPCC ecosystem. And then we have infrastructure and services provided by industry partners. I think there was quite some of that mentioned already in different sessions yesterday. So if you look at with MOC, right, the research in the MOC that's happening, that's interesting for system/cloud researchers, is that we have access to data sets. And I mean, it says cloud data sets on the slide, but it should say more data sets in general, right? So Mercedes was here yesterday to talk about Dataverse and all the other things that are stored there. And so there's information, there's data sets right in MOC that can be used to run experiments. So if you want to have a load for your evaluation, you can actually use that if you want to have a data set. But there's also the telemetry about that. What's going on in this, with that cloud? How much CPU usage, how much memory usage. We can actually measure power, right? We build a system for Cloud Lab, for example, where we have the power usage of your system. So how power hungry is my cloud system, is my algorithm, whatever. So we can figure that out. And we have this strong industry engagement that gives us this nice way for transition to practice, but also sustainability. I'll get back to the sustainability aspect in a moment. But we just heard Mimi talk about this in reply to Oran's question, how important such engagement is, right? And then in the end, the way of exposing some of the experimental services, if they have stabilized to a certain extent, back into the production cloud. Now the goal is here with our CCRI project, how can we make this available to a larger group of nationwide researchers? I should mention MOC is really focused on the region. There's a lot of people from the Northeast area as users, especially from the schools here in the area. And so how can we make this, how can we get a much wider reach? And this is where Cloud Lab comes in, right? So Cloud Lab has built already a large community. Rob, how many users at the moment? Several thousand users? 5,000 users, so that's very impressive, right? It's lots of users. A nice tool set, tool chain. If you have a chance and haven't made up your mind, come to one of the deep dives this afternoon. David is running to see about how you can use a profile to set up your slice in Cloud Lab to get a bunch of resources and then run your own experiments on it. That work. I'm probably using it for too long. I think they work very nice. Hard isolation, right? So if users run experiments at the same time on the same infrastructure, you don't impact them with each other, which is important for reproducibility. I talked about the profiles, and this is where also another community effort comes in. When you create these profiles to describe your experiment, you can actually make them public and share them, and so there's a community benefit. Someone else, students can pick them up, use them, learn from them, and so on. That is all because it has been designed specifically for reproducible research. Probably something where, no, not probably, this is something I believe personally is something really important in our community. Software stack is open source, right? So if you really ever want to go in, change something, improve things, you can do this. And it's federated with other test beds. It's been federated with the good old Genie testbed, right? There's federation with Fabric coming up pretty soon. I'm probably forgetting a couple, but it's highly integrated, and that's a nice thing. So it's scientific infrastructure for cloud research. There were 3 original clusters. We now have a cluster also at MGHPCC that are distributed over Utah, Wisconsin, and Clemson with different aspects in hardware in terms of storage, networking, and memory. And actually, Clemson, since last Friday, I believe, also offers FPGAs, right? Okay. So with Open Cloud, the goal, Open Cloud Testbed, the goal is to, further support research in experimentation into new cloud platforms. And that is, we want to achieve that by combining proven software technologies that come out of, the Cloud Lab project and the reproducibility features with a real production cloud. And we want to enhance that with new hardware by putting FPGA capabilities in our cluster here, in our infrastructure, and look at, actually, it's not only bump in the wire, but a bunch of capabilities for the FPGA systems research community in this case. And in the end, we'll plan to have about 30 FPGAs available for running experiments. So how do we achieve that? Is how do we now go with how can we bring MOC out to the world, so to speak, to a large group of cloud researchers? And that is by, first of all, being able to shrink and grow what's the resources that are available in Cloud Lab. We'll start that with, as you see in a moment, by providing more or less resources in terms of bare metal servers at the Cloud Lab cluster in MGH PCC. We are working, and there was a bird of feathers, sorry, yesterday evening, where people were discussing about some of the technical challenges for ESI, to use ESI to do this transition, for example, to use bare metal servers provisioned by MOC or NERC to take them over into the Cloud Lab universe, so they can be used, and they can be used in times of high demand and can then be released if those high demand times are gone. We actually would like to go all the way long term, so that can be done kind of instantaneous, so that experiments can be snapshotted, and then can be, if resources have to go away, the resources go away, and once the sufficient resources come back, these experiments can start at that point of snapshotting, and you don't have to start all over again from the beginning. That's one of our longer term goals we try to establish. So being able to expand and shrink the Cloud Lab testbed, and then provide, and so we take that into the Cloud Lab universe, so to speak, and then provide or have people now being able to use the Cloud Lab services, the Cloud Lab interface, and the tools to run experiments on top of that. I've shown that before. We have a cluster at UMass, and at MGH PCC, I'm sorry, that now provides about 19 bare metal servers that you can use as of today for running Cloud Lab experiments on that side. The next step is, we're in evaluation of also, for FPGAs, and we're looking into 2 models, which I'm going to speak about in more detail a little bit in a moment, to integrate into the cluster down at MGH PCC, which then will be made public to the research community. I'll speak and have a couple more details on that in a moment. Right? So what's new? FPGAs as reconfigurable compute and bump in the wire, fully accessible to users, is one of the big goals of our project. There's a little bit of a sketch of how this will be integrated into the system, right, where you can have the bump in the wire, but where you can also run it as an accelerator. You still have your regular network connection, and so if you look at this image alone, you can think about all the challenges you can have to make this work in terms of what is your network, what is your data plane, and so on. You can do a lot of things with crazy things on the network or bad things on the network by doing things with your FPGA in a way that can cause havoc. So we have to also think about how we control things. We're providing bare metal services on the servers, but also pretty much on the FPGAs, if I may say it this way. And so the user can do whatever they want, and so that can create problems. So we have to think about how we dam that without completely restricting the flexibility of the researchers that they would like to have. To give you a little bit of an idea how we can make Cloud Labs dynamically scalable by adding and removing third-party resources. Again, we're thinking about doing this originally with MOC resources, But we'll have very good conversations with Scott and Wayne about doing this also with NERC resources in the future. Here, just to give you a little bit of an idea, an important aspect is if you take a bare metal server out of an HPC cluster and have it running in Cloud Lab for a while, where it's the Wild West, so to speak, researchers can do on what they want to on that bare metal server, what they want to do. You want to make sure it comes back into the HPC cluster uncompromised, right? So there's a service that has to run Keylime, actually in this case, that makes it a trusted server, even if it comes back as a bare metal server into the HPC cluster, so it can be used there and not create any problems. Being able to transfer new cloud mechanisms to production, where we can offer them to the production service to the production part of the MOC cloud. I mentioned the access to storage data sets and cloud telemetry. The beautiful thing is that they are all sitting in MOC, so that you don't have to ship data over large distances back and forth. They're right there, especially if you're dealing with large data sets and you have the telemetry information for your analysis or other uses. Collaboration with industry, we talked a little bit about this yesterday already. We got a wonderful donation from 2 Sigma that allows us to move much faster with the initial rollout and helps us with a bunch of testing, because now we have a bunch of resources available we can set aside for a lot of prototyping. And then this allows us also to use parts of Cloud Lab outside the research community, because this is non-NSF funded equipment that can be used by industry and foundation partners, for example. Okay, I talked about the new hardware. Just let me mention briefly. We had an original plan to add 10 more nodes to the existing MES Cloud Lab cluster through our NSF fund grant. I'm sorry, and through the 2 Sigma donation, we can now do this with approximately 200 new servers. New servers for us. They're 2 years old, but that's still perfect. We have already 19 additional servers in the Cloud Lab racks, and now we have 3 additional racks of servers we're getting up and running that we can make available. They can be then part of MOC, part of Cloud Lab, through the flexible, through the bare metal multi-tenant service here. Here's the hardware. On the left-hand side, you see the Cloud Lab cluster with the original servers on top and the new machines in there on the bottom. And on the right-hand side, you see the other 3 racks of hardware we have already installed. They're coming up and operational over the next couple of months. Couple of challenges, right? And I say challenges because these are challenges we are well aware of, because we set them out as challenges we want to tackle and address as part of the project. And one, this definitely the FPGAs, right? The out-of-band management, right? How do we deal with the multi-tenancy of bare metal servers? Network isolation, I want to briefly hint on this. And then also, don't forget, this is out of the SAIS community research infrastructure program, so how do we get broad community buy-in for our project? So FPGAs, the plan is to have 15 FPGAs available by the end of the year, and then 50 in 2022, so in 2 years from now. So then offer, at the end of the project, a total of 30 FPGAs. Miriam and Martin went out, as they already showed you a little bit in their, or to a good extent in their micro talk yesterday on, and surveyed the community. They got about feedback from 20 beta, what they call beta users, who are interested in cloud operating systems, middleware, FPGA systems, FPGA tools, provider applications, and tenant applications. So in all these different areas. I think that shows a great interest in this side. We'll hopefully, with the 15 PGAs, be able to work closely with these colleagues, and then through them reach out to the larger community. We think that FPGAs are really important. You've seen that already. There's a bunch of FPGAs, a significant number of FPGAs in Microsoft Azure Cloud. Unfortunately, they are not available to any user. They're just available to, they're used by the administrators of the cloud. They're used in Azure for their internal operations. No access to it. We see also FPGAs becoming available in other public clouds, and we see them also becoming more and more playing more and more role in high-performance compute data centers also. That's why we think it's a substantial component we should have in our cloud research testbed. We're looking at 2 models right now. As I learned myself since Friday, one of the models has changed. We have been looking at the Xilinx Alveo on one hand, and then also on an Intel FPGA. I don't think the plan is to evaluate both and then decide how we want to move forward with the first 15 ones. You saw Ahmed talk yesterday about the tool chaining, right? So there's quite some effort going on making kind of an open tool chain to allow the research community to use FPGAs, to program FPGAs, and to work with the FPGAs. So that's I think is a very important component here on that side, and in getting the community work and use the testbed. The other part is implications on networking. We have to really think about how we deal with an FPGA where things can go wrong, where things can go rogue, so it doesn't kind of destroy or make the network totally unusable. There's a bunch of challenges that we have to deal with in this area. Let me quickly go over the out-of-band management. This is really, now you have one piece of bare metal. How can you share that between different control frameworks? The long-term approach is that the ESI controls the access to the servers and the switches itself. Cloud Lab will then have drivers for the out-of-band management, the switch control, and the console for the allocated servers. We were thinking of building scripts that allows to perform this allocation automatically. Use Keylime to provide attested nodes back to the production server I just described before. When you want to send a server from, or when you allocate a server that has been in Cloud Lab back into a production cloud into an HPC cluster to make sure they are, secure and are not compromised at all. And then eventually, I talked about the snapshotting enable stateless Cloud Lab nodes that can save and restore experiments if resources have to be returned at a certain point in time and come back online after a while. Our original plan was to do this all before we go and roll the service out, but we changed our approach a little bit by doing a bunch of things in the short term, by giving Cloud Lab and the ESI control software direct access to the servers and the switches. And then each of them will have their inventory of servers and get started with that. It's unsecure because we don't have the attestation service on that side, but in that case, because we're using the pool of the new servers we just got, we don't have to provide a service like this because it's all in the system that is used for experimentation. And the pros on that side is that it's very straightforward. And we think that we can have an elastic cloud available by mid-year. Okay, let me skip that network isolation part because I'm running out of time. What I want to mention also is that I want to again reach out to you, address you as our community, as our, if I may say that in the research area, customers, so to speak, in terms of this is your chance also here to talk to us. How can Open Cloud Testbed support your systems research? What are we missing? What are your specific needs? We really want your feedback. Good news is, as you might see this afternoon, if you're familiar with Cloud Lab, you can use resources at MGH-PCC now, right? The other thing is also, if you are familiar with MOC, you can use the resources there right away. And new services will become online gradually. Hopefully, by the end of the year, we have then a lot more services available for With that, I want to thank the core team. Jen, I don't know why I have you on. So I want to thank the core team. You know, all the great work is thanks to them. All the things that are not working, I'm to blame for, right? So that's my job here as the PI. It's been really good collaboration so far. Definitely also a big thank you to the National Science Foundation for trusting us and thinking of our proposal we submitted last year as a good one. And I hope we can stand up to the promises and the suggestions we made there. Okay, with that, let me stop and open up for questions. Oh, yes. Oh, yeah. Oh, sorry. Totally forgot. I would like to have, just 1 second, Martin, Miriam, Oran, Peter, and David, if you could also come up here so we can have everyone help me answer questions. I need help now. So thank you.
Thanks, Mick.
You're welcome.
Really? So I guess I'll pose a question to the audience then.
Oh,
Well, wait,
now let
you
him
got
go
a
first.
question?
Do you
Okay,
mind?
okay, sorry, good.
you got to build the thing, I get. So I'm John Cohn at MIT IBM, and kind of slightly loaded question. I noticed on your picture that you had this many cloud researchers and this many users. I support a cluster at MIT at the other school, and how do you balance between having a usable cloud to do research and doing research on the cloud? And I want to ask that, and then my second part is, if I ask the cloud users, would they say the same thing, that it's good balance?
So let me go first, and then you can chime in. So some of it is separate, right? There's already MOC has part of the cloud that's production cloud, and that will never completely go away, right? And then we have resources that are dedicated for the researchers. And then there's a pool in between that we can switch back and forth, right? And I apologize, I should have put, and Oran will probably hit me in the head, there should be much more researchers on the user side. There should be many more users on that side because there are many more even for MOC, right? So that's important. So that's kind of...
So partitioning is
but-
good.
Yeah.
That makes sense.
I don't know, how many were here for sort of the kickoff session at the very beginning of the workshop? Were you here, John? Okay, so what we described was 5 interrelated projects. The MOC exists, and it's got a few hundred users, and it's got about 10,000 users of some of the services on top of it, and it scares the bejesus out of us, and we don't sleep a lot of nights because it's a soft-funded project with no facilitators and courses relying on it. So OCT, and so we've had a group of people that have been able to do research in this platform very carefully. OCT is opening this up to the nation's researchers. But the other thing that's happening is Scott and Wayne, if you guys could stand up over there, they're standing up the New England Research Cloud, which is going to be a production cloud hosted by real IT folks. And we're laying them out of the basement for this. And sorry, it was a joke from the first day. But this is going to potentially scale to hundreds of thousands of users. And the idea is these guys are the team responsible for deciding what goes into that. And then there's the oil project. And so the idea is we have this nice mechanism to do innovation here, to have it flow into, be exposed as experimental services that are not considered part of production, but to all the same users of production, then eventually flow into the standardization effort, and then eventually flow into production. So all those components are here. Different people are responsible for them so that if our wacky ideas can't make it into the production side without going through a whole staging process.
And to answer your question, like very directly, for the Mass Open Cloud, we hired someone who his job is when we want to do some research thing on it to say no.
Okay, so I got 2 good ideas out of this. So get a no sayer and partition. That makes good sense. And I'd love to hear. I'd love to meet you guys. Thank you. Good answers.
Thank you.
Can you speak briefly to the hybridity of either the Mass Open Cloud or the Open Cloud Testbed for access to APIs in public cloud providers.
So you mean hybrid between us and public clouds?
Yes.
You know, I think that one of the things that we are doing is in the oil project, right, is we want to stand up compatible clouds and with the feeling that it's much easier to have a hybrid cloud if you're actually deploying the same technology on both sides. You know, if you've got the same containerized environment, if you've got the OpenShift kind of stuff. So that's orthogonal, though, I would argue, to the Open Cloud Testbed. Here's where we want to do radical innovation. So that should be another session question, because this is the place where we want to let researchers go crazy. We want to give them very, very strong isolation, have access to field programmable gate arrays, which, for example, in Microsoft is in every node in their cloud, but it's not available for researchers to actually deploy their own stuff to. So I think this is the place for the radical experimentation.
So I have a microphone. So Paul, actually in collaboration with our friends at Renzi, we have actually, we have a project, Paul's gonna mention, or Anibon spoke about it yesterday. We're actually able to create scientific workflows where we can allocate MOC resources, but we can also allocate Amazon resources through the I2 interface, which I cannot think of the name right now. Guys, help me out.
Direct Connect? Yeah.
Direct, yeah. And so it's not necessarily something we as a core team are able to do, but we have done that in some other projects, and I hope that I'm portraying that correctly, right? Yeah.
Thank you.
Hi. I have a question for Miriam. This pertains to something that came up last night in the ESI BOF, which is that there's a necessity for attestation for nodes. And that's not just a pure security thing, it's actually context sensitive. So what Cloud Lab wants to do for attestation is different than what MOC wants to do. And once you start putting FPGAs into the system in fairly large quantities, how do you see people working on attestation, and where do you think those kind of people are going to come from?
That's a really, really good question. I think that's one of our big challenges. So we keep repeating bare metal, bare metal, bare metal. We can't really give people bare metal access for a whole variety of reasons. We have to be really, really good on the isolation piece in order to let people really play and do all the things we want. So it's going to be a tightrope, but there's a lot of research going on right now in the whole attestation security aspect. Because one of the things about an FPGA is you can pretty much do anything with it. So you could inject dangerous packets into your system. There's all sorts of things that we have to worry about. So it's something that we have to seriously talk about and figure out what the road forward is. But also, as Mike and Oren were saying, that I mean that's also the goal of this project, right? Yes, to provide a community research infrastructure, provide it in such a way that people can really play, and hopefully play safely, so that they don't, do these dangerous things. Do you want to add to that?
You're actively recruiting people who want to do that? Just because I know we have one or two security people in the room who are kind of, active.
Yeah, no, it'd be really interesting to talk about that more.
Yeah.
Okay.
Yeah, I'll just add that Hugh is sitting next to you, or right there, and Ahmed in the back, and this is something that Red Hat is also very interested in, and maybe on Thursday you'll hear a little bit more about this when we visit. So I'm pointing to Ahmed back there. So.
Speaking of recruiting, I think that's an important message we haven't given yet here. I especially want to address the students, and especially want to address the students who are not already, haven't been arrested by Iran or someone else, but are looking for interesting research projects, but also for great opportunities to work in collaboration with industry and the OpenStack Foundation, because I think the whole ecosystem here is a great opportunity in terms of learning a lot about, systems research, about cloud research, with having a lot of access to resources, learn a lot in this area, but also for internships with where's Heidi? Red Hat and potentially OpenStack Foundation with IBM. So I think take this as an opportunity. Come and talk to us. We'd be happy to help you out and guide you in the right direction where your interests are.
I just wanted to expand a little bit on, I think, what Miriam said, because I'm curious, or maybe I'm asking questions, but I think at some level, we can get strong isolation at the networking level. So you can get a group of nodes, you can fully program the FPGA, and you can get strong isolation. I think from the attestation perspective, you know, if you can totally reflash the FPGA from the node, if you actually can boot in a secure way, I feel fairly comfortable from an experimentation perspective. What I think is that that's just the tip of the iceberg to allow, well, first of all, I'm curious if I'm just wrong about that. I'm worried, obviously, about FPGAs that you could blow up the chip if you can program to it. So that I think we're stuck with. But I also think that I'm really excited about the notions that, you know, people like Ahmed have been doing about having a shell on the FPGA so we can share the FPGA between provider functionality and experimental functionality. I think that's all research. I think that this is providing testbed where you can totally control the full FPGA, allows for that research to happen. But is this the way we do the cut in the future? I don't think it is. I think it's going to have to be the right kind of shell mechanisms, or in a sense, the operating system for the FPGA.
There are some minimal things you need to do. So blowing up the FPGA is a real possibility, and people write papers on this. There are some minimal things we can provide to make sure that doesn't happen. I mean, Mimi didn't give us a budget for infinite hardware, so we can't let people just burn up these cards because they're not cheap, basically. And I know Steve Castleman is the person whose brains I'll pick about exactly how to implement that.
Yeah, they have board support packages already built in. In fact, the Althea board won't let you program any of the I/O. You lock all that stuff down, and then it has a bunch of other features that come together to allow you to.
So, but
Will that preclude the
we
research?
want to give people as much freedom as we possibly can, while at the same time providing sort of the minimum, you know, guarantees that they can't do really malicious things. So, you know, we want to, yeah, there will be some, plus users need some sort of infrastructure. So there's going to be some sort of board support package. It's going to be a tightrope to work out how to do this, to both provide security, you know, safety from malicious things, and maybe malicious is the wrong word, because sometimes it's naivety, not maliciousness. Like, researchers don't necessarily want to blow up things for fun, but we might do it by accident.
There's one more question over here.
So I have two questions about the Cloud Lab. So first is, you mentioned, for example, clusters from Utah, Wisconsin, they're sharing sort of resources under this platform. What is the sort of policy in terms of users' perspective when they want to take advantage of these resources? For example, in Utah, I know that there are like priorities within the cluster, that is, who is getting, you know, preemption, who can get resources constantly, or who can get, you know, get out of this cluster. So, and does that differ across different clusters and different institutes, and what is your planning of that? So that's question one. The question two is, how about the storage? So a lot of researchers depend on the storage to do the compute. Now, what is the planning on sharing the, I don't know, is it like sharing the resource, the storage resources on the Cloud Lab, or allocating storage separately?
So we have Rob Ritchie here, who's the PI of Cloud Lab, so well qualified to answer.
I'll take a shot at answering those. And I will say, by the way, there is going to be a panel later today that may be, if we don't want to eat up all of our time in the break, we can discuss more of this in the panel. But so for the other three major Cloud Lab sites, the policy there is, you know, it is to be used for research and education, and it is free to people who are using it for that purpose. So, for example, we have industrial users, but they're, you know, from the industrial labs, right, as opposed to doing, you know, things that are more like product R&D. As far as the kind of allocation between different users go, it's basically a first come, first serve service. We do have a ability to request that you reserve resources in the future, right? So for example, if you're going to run a tutorial this afternoon, you can submit a reservation request and ask to have some resources reserved there. In terms of storage, it depends on the size. Actually, small ones get approved automatically. Larger ones, a human gets involved and looks at it. As far as storage goes, the distinction I'd like to make is sort of the storage that is used as part of a particular experiment versus long-term data storage. So we offer a whole bunch of different possibilities for storage for individual experiments. We have most of our machines have a couple local disks. We have some machines that have like 32 local disks, so you can build your own storage box. We do not provide like long-term archival kinds of storage for users. That's out of our scope.
So
yeah, these guys might want to give a slightly different answer for the OCT.
Yeah. So I think that this is where we're excited. So FPGAs is the first really innovative stuff that's going on here, and I'm really excited about it. But there's the potential. So as Mike was talking about, the researchers have access to production data sets, to all these things from the MOC, and can expose experimental services. They also can just use the storage of the MOC and of NERC if they're from an affiliated organization to actually store long-term archival things. So it's partially the link between the two. But I just wanted to put out a call here from, like, for example, to industry folks from IBM. Right now we've got this infrastructure, but I think we'd love to expose other kind of interesting infrastructure into this that industry would like to sort of see here. And for the sake, at least infrastructure that's donated by industry or committed by industry is available both to industry and to academia for sort of experimentation. Again, not for product development, but for broader set of uses.
Yeah. So one more question, because we're deeply going into our coffee break. So just one question, please, because you've done this twice. There's been two questions.
Fine. So I have one. Let me confine it to an observation. I want a question for you, but I'll ask you in the break. The observation is that you're all keen on attestation, and attestation was something IBM Research did 15 years ago with the initial TPM implementation. We still own a significant parts of the upstream of the attestation stack. So while you're talking to Red Hat about influence in the upstream of attestation, you could also just talk to us in IBM Research. We'd be very happy to listen.
Thank you. Great. And we're around for the break or whatever. I've seen there have been a couple of further questions. We'd be happy to engage with you and answer these questions. Thank you. Thanks for coming up, Rob.